Sounds like a gun rating.
Is it working? Class has begun. So the idea here is that I think I still probably have. I'm writing stuff that deals with crap like this. So just assume this looks scary.
You don't have to assume that.
So this is talking directly to an HTTP server, like a web server. And so I'm passing things in JSON format. And I'll talk a little bit about JSON today, because it's related to what we're doing, actually. In fact, maybe we will do JSON today. We can upgrade. I mean, it actually is very related. So this is kind of showing that what we're talking about right now is very usable for the kind of stuff that we're going to do. So I got to send all these API keys and crap like that. This is the part that doesn't matter that you were talking about. But anyways, I was creating a brand new customer, so you have to format this customer. This is JSON format, what I have highlighted right there. So JSON is a bunch of stuff in between an opening and closing curly brace, and it's a bunch of name value pairs. So we have a variable called active whose value is true, a variable called address whose value is just random crap because I put it in there, a birth date, a credit card expiration date, blah, blah, blah. So it goes through that whole thing, and then we get down to, I don't think I have arrays in this one, but if I actually think it'll be the there we go. Just need to find their address. Okay, like so for example, it's right there. So what I have highlighted right there, this is how they internally store arrays. So we have a variable called addresses, and an address is the addresses variable is actually an array, where the array has JSON inside of it, where each thing is this is what an address looks like. That's what an address looks like inside there. So it's this really scary looking format for storing information, but the reality is that it's not hard. You know, it's just a bunch of comma delimited name value pairs. But when you look at it visibly, it looks difficult, right? Now, what's interesting about this, though, is I'm storing object type information textually. So if I have this stuff, so ultimately what I'm doing is I'm reading in like that wall of text I just showed you, and it comes into the constructor for a customer right here. And then I'm taking that and I'm parsing it out into a bunch of variable names. So I'm turning it from that wall of text into a Java object. And then from a Java object back to a wall of text. So I have a method in here that converts this object back to a JSON string, where I'm building it right here. Does that kind of make sense? So this is pretty much the same thing that we're doing in here. We're manipulating strings in various ways. So that's kind of the stuff I've been working on, so you can imagine what that felt like in size 90 font. Plus I was in my massage chair, so I was like shaking. I was doing open. Okay. So in any case, what we did last time is we took a string that looked like this, and we turned it into a, we pulled out the array that had a string apple, a string bat, a string G, orange, grape, banana, right? And we did that in this single method called string to array, where it took in any string that looks like this, so we can pass it a shorter string, a longer string, whatever. But any string that's in that format where we have a single string separated by white space. And it should turn that into a array, a string array. So the first thing we did is we passed it to our method here called count words. And what did count words do? It went through and figured out how many words were in that string, okay, by looking at the first letter of each one and so on and so forth. Okay, so does that make sense what we did last time? So rather than, instead of JSON, we actually stored the stuff like this. Okay, if we were doing the same thing in let's see, let me do this real quick. Have we looked at creating our own objects yet? Why don't we do that? So what I'm going to do here is I'm going to create a new class. And we're going to name this class let's see, what do I want to do for the initial? I don't want to deal with string parsing in it because I want it to seem simple. Let's do, just for the sake of argument, let's call this guy DiceRoll. Okay? Because we've already messed with some dice rolls. So we have this thing called DiceRoll. And when we think about what a dice roll is, a dice roll is a number of sides and a quantity, right? That's what it is to roll dice. Now, when we wrote our D20 gaming dice, Epic Pro, whatever version thing, we did all this in one giant driver, correct? Isn't that how we did it? Okay. So now I'm showing you how we could have compartmentalized some of that or encapsulated some of that into other objects. So we're going to say for our dice roll, we're going to keep track of something called num sides. We're also going to keep track of quantity. Those are the two pieces of information that we need for a dice roll to work. Okay? Now I'm also going to give myself an instance of the random class. Now notice it underlined random. I'll hover over it, import java.util random. Another advantage of Eclipse, you used to have to type that by hand. Imagine those days. Kind of like when you had to get up to turn the TV on.
You just have mental chips that
Yeah.
turn it on and off.
Who uses a remote? What's a TV? I just watch it inside my head. You just turn your eyes into TV mode. You can watch different channels. You're all on the same couch. Like, what channel are you on? There we go. Wait, pause. Never. Well, some of the new TVs already have this kind of stuff going into these smart TVs where they're using hand gestures and things like that. That's one of the rumors about when Apple comes out with their TV, that it's going to have kind of Siri built into it. Some of it will be hand gestures and some of it will just be talking, you know, tune into ESPN or something like that, and it'll, you know, just go to that channel. You know, so all of a sudden you'll be, you know, when these guys come over to stalk me at my house, they'll be looking through the window and they'll just see me waving at my TV and stuff like that. It's just gang symbols.
He's either telling someone to get out of the way of the TV, or he's summoning Satan.
Well, yeah. Well, it needs to work. Any way you cut it, it needs to work for my cat. Just one of them, just Gracie. She watches soap operas during the day. That's weird, I know.
Like some foreign form of yoga.
It's pretty funny. The other day, she was coming up for we feed her and her sister downstairs so the other cat can take her Prozac and use the litter box. We went to let them up, and Gracie comes all the way up the stairs to the very last step, and then just blops over. I need a breather. 10 minutes later, she finally came up. She needs her rest. All right, so we need 3 pieces of information to do a dice roll, but we're going to create our random. So now I need to write a constructor. Have we talked about constructors yet? Can we just assume no since you're wondering?
Yeah.
Okay. So I'm going to write a constructor here, and the constructor is going to take in two values, num sides, quantity. Notice, the constructor has the exact same name as the class name. Okay? So let's go ahead and come in here. Are you wearing your computer science shirt? So was Brandon today. I mean,
told me to wear it as I was leaving the
oh,
house. So I could, like,
I mean my cup holder. My cup holder was also wearing their computer science shirt today. All right,
You're
so,
buying the G as one too?
huh?
Are you buying the G as a cup holder as well?
Well, I only need one cup holder. I mean, I have a table here. I mean, I'm not that big of a jerk. Yeah, if I,
There's a convenience.
I'd have to have a really long straw. So then I have to have her go and run down to the cafeteria and get a bunch of straws, and then they don't have straws in the cafeteria, do they? That's stupid.
No.
She has to go down to the nest and get some straws. Then she has to do that thing where she links them together. You know that you did as a kid. When was the last time you linked straws together?
Like last month.
Tuesday. That doesn't surprise me. All right, so constructors must have the same name as the class name. Purpose is to build for us an object. And maybe another way of saying that is initialize all of the variables associated with an object initialize all the variables associated with an object to an appropriate, man, I picked a bad word, appropriate starting point. Something like that. Okay? So it allows us to create a new object. So an example might be, like come back out here and go to driver. We've created a random object before. And forget about the underline. We're going to get rid of it here in a second. I'm creating a variable named R of type random, and I'm calling upon the constructor. And that guy will build a random object for me. In this particular case, the random constructor doesn't need any special values from me in order to work. He internally magically initializes this object to work. Okay? So this is the random constructor that we're calling. So at this point, we've called constructors before, but we've never written one. So now we're writing one. So a constructor has to have the same name as the class. Its purpose is to initialize our object, get everything set up so we're ready to start using our object. It looks a lot like a method, but has no return type. Not to be confused with having a return type of void. It literally has no return type. Notice, no return type. Where if we had here, I'll go ahead and write a method we're going to write here in a second. Int roll. Let's return -1 real quick. So here's a method, and I'll throw public in here just so we haven't talked about that yet, but just deal with it. So public's here on both of them, so just pretend like it's not there on either of them. Okay? Notice here's a method. Looks a lot like our constructor here, except the constructor takes 2 parameters instead of 0 for roll. But roll returns an integer. And if it didn't return anything, we would still have to say it returns nothing. We'd still have to say it returns void. Okay? Whereas constructors never have a return value. And let me actually come back out here, and we'll give you a quiz. So here's an example of me calling a constructor. Or if you want to, we'll do it this way. DiceRoll dr equals new DiceRoll, what did I say, sides, and then 620. That's 20d6. So that's how I would create a dice roll. So this is me calling upon that constructor. Does that make sense? Name of the constructor is DiceRoll. It takes 2 parameters, 2 integers. The first one is the number of sides. The second one is the quantity. Make sense? All right. So ready for your. This isn't a written quiz. This is a public quiz, and it should be a little bit difficult. And I'm seeing if you can draw a conclusion here. I said that constructors never have a return type, right? Never have a return type. When you see what a constructor looks like here in action, we would always call the constructor in this way, following the new keyword. Why is it that a constructor does not have a return type? Why does that make sense? Einstein's Autumn Blend, pretty decent. This other one's crappy country club coffee. And that one's
Not
decaf.
even the same coffee.
No, I've been in several different locations today. I've been,
So you knew you needed a lot.
No, no,
So
so
several cups.
so 6:45 I was at Einstein's. 8 o'clock I was at Out of the Box's office, which you don't see that cup represented here, but it's in the car empty. And then I went over to the country club at 9, and that's where that one came from. So that's from their coffee machine there. It's decaf. It's actually not crappy, but it's not like anything special.
It's not like it's gonna kill you with crappy cream.
But I did talk to the chef about making me a special dinner tonight. My wife we have Bible study tonight at the church, and then my wife has some stupid meeting some committee she's on, so I have to go have dinner. So I might as well have something good. So I'm having their chef make me something low gluten, low carb, big portion. Awesome. Hopefully he picks steak and like Caesar salad and scallops and shrimp. And, oh, that sounds so good. Ribs. Stop distracting me. Answer the question. So why is it, do you think, that I've said over on this side where we're defining our constructor, that constructors never never return anything? We never specify a return type for constructor, not even void. And I'm also telling you, here's an example of us calling a constructor in the wild. We're actually using that constructor. And I'm saying constructors always follow the new keyword. We would always call the constructor after the new keyword. That's your hint. I didn't have to say hint since I said always so many times in a row. Why do you think constructors never have to specify a return type? I'll give you another hint. I promise you that constructors do return a value. But why is it that we don't have to specify the type of value? Go ahead.
Is it because it's getting stored in a place in memory?
What? I'm going to say no for right now because you really haven't said it in a very intelligent way yet. But it does involve memory. And I think you kind of understand the concept. I'll give you another minute to come up with a less dumb way of saying it. Go ahead.
Because the new keyword is finding enough memory space for it.
Okay. So between the two of you, you've said a lot about the same stuff, right? Ultimately, what does the new keyword boil down to? So the new keyword finds memory. The constructor builds something someplace, Abe. So that gets stored up in memory, right? So we got the real estate agent who finds memory. Then we're storing crap in memory. Okay, what's the Trinity Christian worldview? bank that. What's the third what's the third leg there? Pointer. Okay. Tell me a little bit more.
It's pointing to that place in memory that it got stored.
What does this guy boil down to right here? What I have highlighted, except I have like multiple crap highlighted. Just the extra highlighted. the darker highlight. What does that boil down to? What kind of value? Cat, dog, ketchup, int, memory address. Correct. So constructors always have a return type of ketchup, therefore you don't actually have to specify it. What does that boil down to? What kind of value does that always boil down to? A memory address. Constructors always boil down to a memory address. 100% of the time, they boil down to a memory address. Therefore, we don't have to specify it, especially since Java doesn't give us a clean way of specifying it.
No such thing as a
That's right. That's right. Now, just to kind of, have we talked about the keyword, this keyword in here?
Yeah, I think you mentioned it. Or maybe it was in the other class.
That's fine. Yeah. Just so you guys know, if I ever like start talking about stuff, I'm just assuming you know it and you've never heard of it before. Just tell me. I teach a lot of different classes, all dealing with similar subjects. So I'll still laugh at you, but tell me. Okay, so I'll give you the punchline here in a second then. But in any case, we have no return type here because this guy always will boil down to a memory address. That make sense? So if something always boils down to a certain type of value, from an efficiency perspective, it makes sense for us not to have to say it, correct? But the side effect of that is that we have something that looks a lot like a method, but actually is a special case where it's a constructor. That makes sense? So how can you tell the difference between a constructor and a method? Two ways. There's two ways that you can identify a constructor from a method in the wild. Way number one is what we just talked about. Constructors never have a return type, right? Okay, here, I'll create a slide for this. Constructor versus method. Whoa, I messed that up pretty bad. Constructors, there we go. Oh, speaking of dumb things I did today. So we're sitting at our meeting this morning at Out of the Box, and Brandon, this involves Brandon, Trista. So Brandon, cup holder. My cup holder's next to me. He's also holding my laptop. But I kind of have a brain fart, and I forget that he's holding my laptop. I have him holding everything. So, because I had somebody else's laptop. Well, no, I was messing around with the iPad. But in any case, I look over, and he has my laptop on his lap. And, my laptop's identifiable because it's the small MacBook Air. I said, oh, when did you get one of those? But I immediately caught myself as soon as I said it. It's like, that was really bad. Like, wait a minute, that's mine.
He should say, just now.
He should have. I tried to sell this the other day. So now I'm having to do a bunch of programming. I'm going to get one of those bigger deals. But maybe it's not a big deal anymore now that I can have font that fits on my screen. I can't even debug by printing out a single variable. In order to check my code, I had to project it onto my TV set. And you needed more screen real estate. Okay, so constructors never have a return type. What's the other way we can identify a constructor from a method?
It's called.
Let me specify. What's the other way that we can identify a constructor from a method when we're looking at them being defined? Certainly by the way it's called. That's not an unfair statement, because if we see the new keyword, that guy's definitely followed by some sort of constructor. From our perspective right now, it's either followed by a constructor or it's followed by the constructor for an array. Let's just call that a constructor thingy, okay? But it's always going to be followed by either a constructor or an array, the array builder. But if we're talking about over here at definition, where we're defining a constructor or we're defining a method, what's the other way we can tell them apart besides one has a return type and one doesn't? Go ahead.
The constructor has the same name as the class.
That's it. So constructors always have the same name as the class name. In Java. And I'll give you the punchline to that in a little bit after we talk about the this keyword. Whoa. Too much caffeine today.
Don't you always have the shake?
Yeah, but it's usually not this bad. It's actually it was funny. I was making, was it yesterday they had Caesar salad in the cafeteria? Or some sort of chef salad station thing. They had Parmesan cheese at the end of it. I was doing a pretty interesting tremor thing with the Parmesan cheese. That's one of the motions I should not do alone. So I was flicking Parmesan cheese up into the air. It was pretty funny. Okay. So, makes sense? Constructors versus methods. Now, we want to go ahead and notice our constructor is taking in two parameters, a number of sides and a quantity. And we want to go ahead and set these guys. Now, if you had to give a name to these guys, what would you say these are up here? Let me ask this a little bit differently. Classes. A class holds three different types of things. What does a class hold? Methods? Okay, I agree with the variables, but we're going to give a new name to it. And constructors. Three things. Methods, constructors, fields. So inside of a class are local variables. You might say these are global variables available anywhere within this class. They're referred to as fields. It's not important that you understand, that you remember that word. I guess that probably is somewhat important from reading a documentation perspective, and we'll look at that at some point. But it doesn't make them extra special. It just, a field is a variable that's global within an object. Okay? So I have two fields here. One's called numSides, one's called quantity. Well, I actually have a third field called random as well. So one of the things that I'm going to do inside of a constructor when I first build the DiceRoll is I'm going to go ahead and give a value to my random object. I didn't need any input into my constructor. I didn't need any parameters to do that. That's just part of the setup. So when I bring this a DiceRoll object into existence, when I create an instance of a DiceRoll object, I'm going to have to initialize my random object so I can roll dice. Make sense? Okay, but now I took in two parameters here. Now these are local variables. Those variables live and die with this constructor. Yet, don't you think later on when I call this roll method, I'd like to have access to the number of sides and the quantity? I'm probably going to need those guys if I want to roll 20d6, for example. I'm going to need access to the number of sides and the quantity that were passed into the constructor. So I'm going to have to store them somewhere. Where am I going to store them? I'm going to store them in these fields. Okay? Now, I purposely named my fields the same thing that I named my parameters. And here's why. Well, I want to set my field numSides equal to numSides, and I want to set quantity equal to quantity equal to quantity. Well, what do I really mean? I want this guy to be this guy. And I want this guy to be this guy. So I want to set my global numSides variable equal to my local numSides variable. That make sense? That's what I'm trying to accomplish. Yet I cannot uniquely identify those two variables here. Does that make sense to everybody? Right now I have a problem. When I say numSides in here, I can't uniquely say whether I mean this version of numSides or this version of numSides. So as of right now, if I'm inside the local environment created inside this method, or created inside this constructor, anytime I say numSides, that will resolve to the most local definition of numSides, which is this guy. So notice when I highlight this, it all points to this guy. The guy up here is not highlighted. So I need a way for an object to refer to his fields, which allows me to supersede any local definition of things. Okay? And the way we do this, I'll just show you first, then we'll talk about it, is I say this dot numSides, this dot quantity. So this dot numSides refers to this guy up here. So when I highlight numSides here, see how it's this one? When I highlight numSides here, it switches to this one, shows us the scope. Okay, so this dot numSides is the field associated with this object. numSides will boil down to the most local definition of numSides. Keeping in mind that if I had taken in a parameter here called ns instead of numSides, when I say numSides here, its most local definition is the guy up here. That make sense? So a lesser programmer would have just said, well, I'm going to get past this problem by just naming my variable something different than my field. Then you don't need to say this dot. You can just say numSides is equal to ns. You'd be a cheater.
Why is that cheating?
Well, I'll tell you. Specifically, it's cheating in Java from a name your variable something that makes sense. In Java, the only way we know what these parameters mean is by how we name them. So if you look at the constructor for DiceRoll and you see that you have a variable called ns, you're going to have to extrapolate that ns actually means numSides. You're going to have to figure that out. Where good programming practice would be name your variables in such a way that they are self-documenting. In Objective-C, and you've seen this, in Objective-C, and I'll show you the rest of you an example here in a few minutes with that after we talk about this, this keyword. This is difficult because it's hard to teach about the this keyword without using the word this 1,000 times. Okay, but in Objective-C, when we create methods or constructors, we would say init with number of sides, ns, and quantity, q. So we spell out, it gives us the way to give semantics to the method. Where in Java, we don't have that luxury. In Java, the only way we can describe to the person who's using our object what it requires as parameters is to name our parameters in such a way that they make sense. That make sense? This. Which? KK, thanks. Okay, so that doesn't mean it's wrong. It does not mean it's wrong to do that. But it is cheating if you're only doing that to avoid having to say this dot numSides. That's what I would say. Okay? Because that means you don't understand the concept of the this keyword. And the concept of the this keyword is very, 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 very important. So we're going to leave this at numSides for now. And we'll say this dot numSides there, and we'll say just numSides here. Okay? So, does everybody understand that when I just say numSides, why it references this one? A variable always resolves to its most local definition. And this local definition of numSides is said to shadow the more global definition. So when I just say numSides here, it resolves to the most local version of it, not the next global one. Okay? And just to kind of give you an idea how that sort of works, I'm just going to make up a variable called chocolate. Okay, so notice if I highlight over chocolate, it's going to say chocolate cannot be resolved to a variable. Let's go through the path that it tried to do in order to find chocolate. First thing it did is it looked in the local environment. Do we have a variable there named chocolate? We do not. So then it said, all right, let's continue our search. So it went out one layer to the next most local environment. Do we have a variable there named chocolate? We do not. Now, visually, we might say, okay, we're done looking. But the reality is we're not actually quite done looking. We're going to learn about a subject in here called inheritance. Inheritance is the creation of an object in terms of another object. So for us, we've all inherited some traits from our parents, and our parents inherited traits from their parents, and they inherited traits from their parents, and so it's all passed down through the generations, right? Well, even though we haven't specifically done any inheritance here, there's a hidden one that is there. I'll explain this here in a second. So the way we accomplish inheritance is through the extends keyword. Not overly important for us right now because we're not going to actually use inheritance yet, but I just want to say that this is something that's there. Just like methods all have a return type, but we don't have to type it. Okay? And this will actually work. You can type this if you want and it won't hurt anything. But let me put this in context for you. This is how all object-oriented languages work, actually. There must be a baseline, a top of the hierarchy. There exists in any object-oriented language a top-level object called object, or something along those lines. In C#, it's object with a lowercase o. In Objective-C, it's NS object with a capital NS and O. All right, but in any case, there is a top-level object that is called something like object that is part of the language. It must exist in order to create any other objects. Okay? So when we just created our DiceRoll, DiceRoll was made in the image of object. So a DiceRoll is a object, but then it's something more. So a DiceRoll gets everything that is built into object, whatever those things are. We could just, for right now, we could just assume object has crap in it. Okay? So DiceRoll gets all of that crap. But then we are extending that and saying, a DiceRoll has a couple of other things. It has a number of sides, it has a quantity, and it has a random object associated with it. And then it has this constructor. And it also has this method. Does that make sense? So in any object-oriented language, we have a top-level object that every single object inherits from. So we just wrote DiceRoll to inherit from that. All right? Now, we can actually create more objects. Maybe we create something called a, I don't know, super DiceRoll, whatever that means. Okay, so we have a super DiceRoll, and a super DiceRoll is everything that a DiceRoll is, plus maybe a little more, something that we do to make it a little different, which is everything that an object is. And we can just keep going down that. We can have, you know, this is us, this is our parents, this is our grandparents. Make sense? Okay. So, even though we don't have to explicitly write it here, all objects that we ever write will at some level inherit from object, either directly or possibly indirectly. So for instance, in this model here, super DiceRoll extends DiceRoll, where DiceRoll extends object. So that's how we actually got our things from our grandparents in this example. All right, but that's not required to be there. It's just assumed to be there, but it won't hurt anything. So my point there was, and let me actually put that back real quick. When we looked for chocolate, we looked at our most local definition here, or most local environment. We didn't find chocolate defined there. Then we looked at our next most local environment, there. We didn't find chocolate defined there. Well, then we have to pass it up to our parent, up to object, to see if chocolate was defined there. And even though we're not looking at object, can we probably assume chocolate was not defined there? All right, so that's when we actually exhausted all possibilities and can say chocolate does not exist as a defined variable. That make sense? Okay. Now, let's talk about the this keyword. Super, super, super important. It's in your top 5. The this keyword only exists inside an object definition. And it gets created within the constructor of the object. Even though, we look in here real quick, do you see me doing anything with the creation of this in here? I'm using this, but this supposes it's already created, right? Okay, so I don't see it in here. I promise you it's in there. But because it always happens, Java doesn't make us write it. Okay, so the this keyword only exists inside an object definition, and it gets created within the constructor of the object. The this keyword is how an object can refer to itself within itself. And what I mean by this, kind of as an example, when you refer to yourself, you say me or my. That's equivalent to saying this. I don't refer to myself as Mike. People find that weird, right? We make fun of people for referring to themselves in the third person because that's how other people refer to me, right? So if I'm talking about Mike, if I'm talking about my dice roll, outside of the dice roll, I refer to it as dr. That's the name of the variable. So similarly, if I create a human named Mike, and this guy's a new human, just bear with me that we wrote that object. Okay, so we have a human named Mike. That's the name of the variable, and it's a new human. Externally, we say, oh, that's Mike. Okay, that's Amish. But if I were inside of this object, if we were over here inside of the human class, and I was inside this particular instance of the human class, the one that Mike points to, the way I would refer to myself is me or my. Or in Java, I would refer to myself as this. So this is how an object refers to itself within itself. So it's like saying me or my. Does that make sense? And I'll go ahead, just since it's in the same vein, I'll throw a second slide in here. Super keyword. This is created at the time, this is, here, I'm going to use the same languages. I'm going to use the same languages back here. only exists inside an object definition. It gets created within the constructor of the object. That's how we refer to our parent. It says super. So maybe the example there would be other people would refer to my dad as Larry. I refer to my dad as Dad. So internally, my parent is super, or other people are going to call my parent by whatever their actual name is. Kind of make sense? Okay. And this goes back, remember, the point of object-oriented languages is to allow us to solve problems similarly to how we solve problems in real life. Okay, so this keeps following that model. All right, we're not going to actually use the super keyword for a little bit. We'll start dealing with that once we start dealing with inheritance. Right now, I'm just kind of telling you inheritance exists. And we're technically using it whether we like it or not. It's part of how object-oriented languages work because of this deal, this thing. Okay? All right, so now when we create a dice roll, we're going to pass in a number of sides and a quantity. We'll set this particular instance's num sides variable equal to whatever num sides that was passed in. We'll set this particular instance's quantity to whatever quantity was passed in. And then we'll also initialize our random object so we're ready to go. We can use it. Make sense? And then we're going to go ahead and create a roll method here. And our roll method needs to sum up rolling this many of this sided dice. So we're going to say int sum is equal to 0. Start that off at that. Now we're going to roll quantity number of times. How do I do something some number of times? 3 ways human beings solve problems. Memory, asking questions, repetition. How do we simulate repetition? Through loops. And I'm doing something a quantity number of times. How many times is that? Some quantity, but a number, right? It could be 5, it could be 20, it could be 2. So what kind of loop lends itself to this? Okay, I hear, who said for loop? You said while loop. Who's right?
Well, it depends on if you know how many times you're going to need to go through the loop at the time.
Don't we? If I'm inside roll, how many times am I going to have to go through that loop? So right here, answer the question how many times I'm going to have to go through that loop. Yes, you do. Give me trust in those.
Quantity.
Quantity times. We know quantity holds a value, right? Okay, it holds some number. We might not have looked into the bucket, but we know that inside that bucket there exists a number. That's how many times we're going to have to go through it. So we do know it, even though we can't tell you. Understand the difference? Okay. Now, having said that, there's no reason why we couldn't use a while loop here. While loop would work just fine, but a for loop lends itself to this problem because it lends itself to counting type problems, specifically problems where we know how many times we need to spin. And we do know how many times we need to spin here. We need to spin quantity number of times. As opposed to an example where we use a while loop where it's like, keep doing something until somebody presses a key. You know, that's completely random when they're going to finally press a key. Quantity is not random. That has a value in it. We're going to go through and do something quantity number of times, however many times that is. So we'll create our for loop. For int I equals 0, I is less than quantity, I plus plus. And what are we going to do each time? We need to roll our dice. Now, I want to use my random object to roll my dice. what range of values do I want to get? What's the smallest value that any dice should give me? 1. Dice don't have zeros on them. Well, not like normal dice. There might be zeros like Uno or something. Or, not Uno, but you know what I'm saying. There might be some stupid games that have a 0 on the dice, but typical dice, when you roll it, you're getting at least a 1. Okay? What's the maximum size? What's the maximum value that I want to generate?
On a typical die?
Huh?
On a typical die?
Yep. Okay, I get what you're asking. No, in this case, right here. Right here. I want to generate a number, gen number between 1 and what? One in num sides. Num sides holds the number of sides that the dice has. Might be 6, might be 8, might be 10. Okay? So, if it's a 6, I want to generate a number between 1 and 6. How do I generate a number between 1 and 6? Have I shown you the most bestest version of r.nextInt yet? We've done the whole mod thing? Okay. Well, here, this will be a good opportunity for this. Let me show you the Java documentation, java.sun.com. Okay, let me make sure you can read this. Is that good? Actually, you probably could have read that. No way I could have read that on my screen. Go down to Java APIs, Java SE7. Now, just as an example here, when we put random in, remember I had it underlined it in red, and then we imported it from java.util. That's the package it's in, is java.util. So inside the documentation, I'm going to show you how to find that. Upper left-hand corner, it shows us all the packages, and one of these packages will be java.util. Right here, java.util. So we'll click on that. And that shows up down here. So now we'll scroll down through all the classes, and we find random in here. Click on that. That brings up the random class, the documentation for the random class over here on the right. So we'll scroll down, and we're used to using the nextInt method, right? And what is the nextInt method? Just before we get into this, I can generate a random number in here by saying r.nextInt, right? What can you tell me about the nextInt method there? Class method or instance method? Instance. How do you know? Somebody else. Go ahead.
Called by an instance of the class in which it was defined.
Called by an instance the class in which it was defined. Okay? So we know this is an instance method. How many parameters does it take? I'm calling it correctly here. How many parameters does it take? 0. How do you know? Nothing inside the parameter list. Okay? But you're right. We have to look at the documentation to be sure. I'm just promising you I'm calling it correctly here for the old school one. The one we've seen already. All right? So let's go to the documentation here. We'll go down. We'll find our... You see that good? We're legit there? So we'll go down to our nextInt method right here. Here's the nextInt method. Now, if we were just looking at this to begin with, is this a class method or instance method? This is the documentation. This shows us the method headers from where they're defined. So how is this a class method or instance method? You already told me it's an instance method from the way you saw me call it. Because you said we're calling it using an instance of the class in which it was defined. How do I know this is an instance method in here? Go ahead. No static. So we don't see the static keyword out front here. Okay? If it was a class method, we would see static, then int. Okay, but we know it's an instance method because there's no static here. So here's our nextInt method. This guy returns the next pseudo-random, uniformly distributed int value from this random number generator sequence. Fine, whatever. What kind of value does this return for me? An int. How do you know? Right there. Okay, it's an int because this is the return type. Name of the method is nextInt. Here's the parameter list. There's nothing in it, and this is what it returns. So this guy's going to return an integer. Specifically, when I call r.nextInt, what kind? Give me the range of values I could get. Go ahead.
Negative to positive 2 billion.
Plus or minus 2 billion. So it's across the range of all ints is what this guy gives us. Okay? Now notice, one line down, we have a second method called nextInt. Class method or instance method? Instance method, how do you know?
No static.
No static. Okay, how many parameters does this guy take? One parameter. But it's the exact same method name. So we have two methods with the same name with a different number and or type of parameter. This is called, you maybe have heard me reference this before, polymorphism. A dumb, scary word that just means more than one method with the same name. That's what polymorphism means. Okay, polymorphism is a object-oriented programming vocabulary word, if you will. And very often this is a quiz question at the CS get-together. This is kind of my go-to phrase for evidence that, I don't know, complicated, all things tend to come up with complicated, give complicated vocabulary associated with it to make it sound harder than it is. Right? Polymorphism sounds way more complicated than just say, oh, you got a couple methods with the same name. I don't know, how else would you even say that? Just, oh yeah, there's two methods, which one are you calling? Which version? Who knows? But in any case, that's the scoop with polymorphism. But more importantly for us, we have a second version of the nextInt method that returns a pseudo-random, uniformly distributed int value between 0 inclusive, so including 0, and the specified value exclusive, where the specified value is the parameter we pass in. Okay? So, how would you call this method to give me a number between 1 and num sides? Go ahead.
Does the exclusive mean that the specified value, you can't get the specified value?
Correct. So if I passed it a 40, I would get a number between 0 and 39. So the 0 is inclusive, the 40 is exclusive. So I want to do what? I want to say r.nextInt, passing it what is a parameter? I want a number between 1 and num sides, including num sides. So if it was a D6, I should get a number between 1 and 6. Go ahead.
Put num sides in the parentheses there. And then outside you need to have a +1.
Okay? So this is guaranteed to give me some number between 1 and num sides, correct? Because this right here is guaranteed to give me a number between 0 and num sides minus 1. So if I add 1 to any number between 0 and num sides minus 1, I'll get a number between 1 and num sides. And what am I going to do with this? I'm going to say sum plus equals that. That make sense? And then ultimately I will return sum. So that's what my roll method does. My roll method creates a brand new sum variable, starts it off at 0, repeats quantity number of times. What does it do each time? It generates a random number between 1 and num sides and adds it onto my running total. And then ultimately, it returns sum after it's done it the correct number of times. Make sense? So let's get rid of this human line here. So there's my dr. So I could say system.out.println dr.roll. And let me go ahead and just comment out these lines up here so we're not using them. All right, so what does main say do? Main says create a brand new DiceRoll object that represents 20 d6. And then let's go ahead and let's roll the dice and print out the result. So there's my 62. And to prove that every time I call the roll method, it rolls the dice, we'll do it 4 times. So there's 4 different rolls. Make sense? Okay, now, right now our dice object has a couple of loose screws in it. We have some access to our object that we might not necessarily want. So if we think about our object as being like a house, and we have a bunch of wires behind some drywall, right now we have a big hole in one of our walls that allows us to get in there and mess with stuff that we might not necessarily want to be able to do. What I mean by that is I can say dr dot quantity equals 500 right there. I can directly access one of the fields of my object. How do I know this is a field? How do I know this is, when I'm looking at it here, how do I know that is a field? What I have highlighted. So if I just showed that to you on a quiz, I said, tell me what quantity is just by looking at that right there, you would tell me it's a field. Why? Go ahead. How do you know it's holding a value? Just to kind of explain that a little bit. I'll create a second constructor, also an example of polymorphism. What does this constructor do? Nothing. So now, instead of calling this version of the constructor, I'll call that version of the constructor, where these lines no longer work. Well, they'll no longer make sense. It'll deal with the default value. So now, quantity does not hold a value, or does not hold a known value. It holds whatever the default value was. So if I just showed you that line right there, why would you say that's a field? What's a field? If you had to define what a field is, what would you say? What are objects filled up with? Objects are filled up with 3 different kinds of things. 3 different animals. They're filled up with methods, constructors, and fields. What's a field? Field is not a method and not a constructor. It's the other guys. Our fields are variables that are global variables to our object. That's what a field is. Okay? But this, you're seeing this over here at the class definition. Now if we come in here to the use of this class, what is dr right here? Dr is a variable that holds a pointer to an instance of DiceRoll, right? So when I say dr.quantity, I'm telling you quantity is a field. How do you know? Well, let's go off Angela's suggestion. How do you know it's not a method? Let's go that route. Let's start ruling crap out. How do you know this is not a method?
It doesn't have a parameter list.
No parentheses, no parameter list. Okay? How do you know it's not a constructor? Okay, that's one way. We know there's no new keyword. I might throw in a second way as you would never call a constructor like this. Just trust me, once you have some experience with it, you'll know that that's a true statement. What else? What's the most obvious way of saying this is not a constructor? Quantity is not equal to, well, you can also say there's no parameters, no parameter lists. Constructors all have parameter lists. But quantity is not the same as what? DiceRoll. Doesn't have the same name as the class. All right, so we know it's not a method. We know it's not a constructor. Must be a field. So you can identify fields real easily by just saying there's no parameter list. Therefore, it's none of the other guys. So it must be a field of whatever this guy is. That make sense? All right. So let me go back here, throw this back in. Okay, so we're going to roll 20d6 3 times, and then we're cheating. We're directly breaking into our object and directly changing one of its values. Okay, it's like opening up a telephone and screwing around with some wires or something like that. You know, but let's say breaking into a payphone, not that they exist, but breaking into a payphone and changing it so that it no longer requires coins to work. You know, we're tampering with our object in such a way that maybe we didn't mean for it to be tampered with. So that last time, it's now going to roll 500 d6, where we might not want to give ourselves access to that. Make sense? So what we'll start off talking about next time, I'll go ahead and throw the slide up real quick. Security, public, private, protected. Make sense? So we'll talk about how we can use those things to solve this problem. All right, I'll see everybody on Thursday.